Welcome. 7th Standard Science Part 1, Chapter 4 Acids, Bases and Salts. As per 2025-2026 Karnataka State Board Syllabus, exercises, the state differences between acids and bases. Question number 1 Property, acids, bases. Taste, acids, sour taste, bases, bitter taste. Litmus test turns blue litmus red. Acids turns red litmus to blue. Iron released in water. H plus ions, OH negative ions. Reaction with metals. React with metals to produce hydrogen gas. Generally do not react with metals except amphoteric metals like Al and Zn. Zn means zinc. Peel. Usually corrosive, may sting. Acids. Bases slippery to touch. Reaction with bases and acids. Acids neutralizes bases to form salt and water. Bases neutralizes acids to form salt and water. Examples: HCl, H2SO4, citric acid, NaOH, KCaOH twice, NH4OH. Second one, ammonia is found in many household products such as window cleaners. It turns red litmus blue. What its nature? Ammonia, NH3, turns red litmus blue, which is a character property of bases. Alkalis. Nature of the ammonia is basic, alkaline. That's why it is used in household cleaners. Bases help to remove grease and dirt effectively. Third one, name the source from which litmus solution is obtained. What is the use of this solution? 1. Source of litmus solution. Litmus solution is obtained from lichen, which is a type of plant-like organism growing on rocks and tree bark. Uses of the litmus solution. One is to test acids and bases. First one turns red in acidic solution. Second turns blue in basic solution. 2. Helps in identifying whether a substance is acidic, basic, or neutral. Question number 4. Is the distilled water acidic, basic, neutral? How would you verify it? One is nature of the distilled water is neutral. Distilled water has no excess H plus or OH negative ions, so its pH is 7. How to verify it? One is using litmus paper. 1. Dip the red litmus to the paper, stays red. Second, dip the blue litmus paper, stays blue only. No color change, that's why water is neutral. Second one, using pH paper or the pH meter. One is pH of distilled water is 7. Confirming it is neutral. Question number 5. Describe the process of neutralization with the help of an example. Neutralization definition. Neutralization is a chemical reaction between an acid and a base that produces a salt and water. General equation. Acid plus base is equal to salt plus water. Example. Reaction between hydrochloric acid and sodium hydroxide. HCl, acid, NaOH, sodium hydroxide, base equal to NaCl, salt plus H2O, water. Soil using lime, CaOH twice. Explanation. H plus ions from the acidic combine with OH minus ions from the base to form water. The remaining ions, Na plus from the NaOH and Cl minus from the HCl, form sodium chloride, which is salt. Application of the neutralization. One is antacids for indigestion, antacids we can say. Second is treatment of acidic or basic chemical pills. Third is in agriculture to neutralize acids. 6. Mark true if the statement is true and F if it is false. One is nitric acid turns red litmus to blue. False. Acid turns blue litmus to red. Second one, sodium hydroxide turns blue litmus to red. False. Because base turns the red litmus to blue. Third one, sodium hydroxide and hydrochloric acid neutralize each other and form salt and water. True. Fourth one, indicator is a substance which shows different colors in acids and basic solutions. True. Oh, fifth one, tooth decay is caused by presence of a base. False. Tooth decay is caused by acids. 7. Dorji has few bottles of soft drink in his restaurant, but unfortunately, these are not labeled. He has to serve the drinks on the demand of customers. One customer wants the acidic drink, another wants basic, and the third one wants neutral drink. How will Dorji decide which drink is to be served to whom? Dorji can identify the nature of the drinks using a simple litmus test. One is take a few drops of each drink in separate small cups. Second, test with a red and blue litmus paper. Litmus test results turns blue litmus red, that is acidic, turns red litmus blue, that is basic. No change in red or blue, that litmus, that is neutral. Third one is serve accordingly. Customer wanting acidic drink, serve the drink that turns the blue litmus to red. Customer wanting basic drink, serve the drink that turns the red litmus to blue. Customer wanting neutral drink, serve the drink that did not change either litmus paper. This way, Dorji can quickly and safely identify which drink is acidic, basic, or neutral. Eighth question, explain why. 1. An antacid antacid tablet is taken when you suffer from acidity. Reason is acidity occurs due to excess HCl in stomach acidic condition. Antacid contains a base like MgOH2 or CaCO3, calcium carbonate, which neutralizes the excess acid. Acid plus base is equal to salt plus water. This provides relief from heartburn or acidity. The calamine solution is applied on the skin when an ant bites. Reason, ant bite inject acid into the skin causing pain and irritation. Calamine solution is slightly basic, which neutralizes the acid and reduces pain and itching. C. Factory waste is neutralized before disposing it into water bodies. Reason, factory waste may contain acidic or basic chemicals that can harm the aquatic life. Neutralizing the waste using a base for acids or an acid for base ensures the pH becomes neutral. It is 7, making it safe for the environment. In all cases, neutralization is used to counteract harmful acids or bases. Ninth one, three liquids are given to you. One is hydrochloric acid, another is sodium hydroxide, and the third is a sugar solution. Which will you identify them? You have only turmeric indicator. Since we have only turmeric indicator, we can identify the liquids as follows. Step 1. Test each liquid with turmeric paper. Observation, conclusion. Turmeric paper turns red. Liquid is basic, sodium hydroxide. Turmeric paper, no change, could be acid or a neutral or sugar solution. Step 2. Distinguish between the acid and the neutral liquid. Add a small piece of sodium bicarbonate, baking soda to liquids that showed no change. If fizzing occurs, it is acid, HCl releases O2 gas. If no fizzing, it is neutral, sugar solution. Summary of the identification is: one is turns turmeric red, sodium hydroxide base. Second, fizzing with baking soda, hydrochloric acid, acid. Third one is no change, sugar solution, neutral. 10th question. Blue litmus paper is dipped in a solution. It remains blue. What is the nature of the solution? Explain. Observation. Blue litmus paper remains blue. Conclusion. The solution is either basic, alkaline, or neutral. Explanation. The blue litmus turns red in acids. Red litmus turns blue in bases. No change in either the litmus paper. Solution is neutral. Since the blue litmus did not change, the solution is not acidic. To check if the neutral or a basic, we can test red litmus paper turns to blue basic, no change neutral. So the solution is either basic or neutral, but definitely not acidic. 11th question. Consider the following statement. A. Both acids and bases change the color of all indicators. True. B. If an indicator gives a color change with an acid, it does not give a change with a base. Now, all indicators change their colors with both acid and base, like this. These are. C is if an indicator changes the color with a base, it does not change the color with acid. Not like that. Is also false. D. Change the color in an acid and a base depend on the type of the indicator. Yes, it is true. That's why which of these statements are correct? A and D are correct. Option 2 is the answer. A and D are correct. And let's discuss why both the acids and bases change their color color of all indicators. True, because indicators are substances that show different colors in acidic and basic solutions. B. If an indicator gives a color change with an acid, it does not give a change with a base. False. Not all. Most indicators change color in both acids and bases, just differently. See, if an indicator changes color with a base, it does not change a color with an acid. False. Same reason the above. This one. Most indicators change their colors in both acids and bases. The change of the color in an acid and a base depends on the type of the indicator. It is true. Different indicators show different colors in acids and bases. For example, litmus paper is there, but we have red and blue litmus papers. Phenolphthalein, methyl orange. These are indicators. Please like, share, subscribe, comment, and save the playlist. Thank you very much. Bye bye.